Spectrum: the splitting of a beam of light into radiation of different wavelengths or frequencies after passing through a prism or diffraction grating is called dispersion, and pattern of radiations observed after the dispersion is called spectrum. Spectroscope or spectrograph is an instrument used to separate radiations of different wavelengths or frequency. Depending on the source of radiations, the spectra are broadly classified into emission spectra and absorption spectra. Emission spectra: it is obtained from the substances which emit light on excitation, that is, either by heating substances on a flame or by passing electric discharge through gases at low pressure, or by passing electric current discharge through a thin filament of a high melting point metal. Emission spectra are of three types: continuous, discontinuous, and band. Continuous spectrum: when white light is allowed to pass through a prism, it gets resolved into several colors. The spectrum is a rainbow of colors, that is, violet merges into indigo, indigo into blue, blue into green, and so on. This is a continuous spectrum, that is, there is no short boundary between two colors. Example: light from the sun, the filament of an incandescent bulb, flame of candle, or a carbon arc can give spectrum of this type. Discontinuous or line spectrum: when gases or vapors of a chemical substance are heated in an electric arc or in a Bunsen flame, light is emitted. If the ray of this light is passed through a prism, a line spectrum is produced. The lines are separated from each other by dark spaces. Each line in the spectrum corresponds to a particular wavelength. The line spectrum is also known as atomic spectrum. The pattern of lines are unique for each element. Hydrogen spectrum is an example of line emission spectrum or atomic emission spectrum. Let's see hydrogen emission spectra here in detail. When an electric current is passed through a glass tube that contains hydrogen gas at low pressure, the tube gives off blue light. When this light is passed through a prism, four narrow bands of bright light are observed against a black background. How spectral lines are forming: when an electron transitions or jumps from a higher energy state to a lower energy one, spectral emission occurs. To distinguish between the two states, the lower energy level is denoted by N1, while the higher energy state is denoted by N2. The energy difference between the two states corresponds to the energy difference of a photon emitted, because the energy of each state is fixed. So it is the energy difference between them, and the transition will always generate the same energy photon. How to calculate the energy of an electron in the Bohr's orbit of hydrogen atom? The energy En equal to minus 13.6 electron volt divided by n square, where n is the principal quantum number. If the electrons are present in the first excited state, that is n equal to 2, then the value is minus 3.4 electron volt. If the electrons are present in the second excited state, that is n equal to 3, then the value is 1.5 electron volt. If the electrons are present in the third excited state, that is n equal to 4, so the value is 0.85 electron volt. Hydrogen atom forms the simplest spectral series of lines. When a light or radiation beam enters the device through a slit, each individual component of the light or radiation forms an image of the source. When resolved with the spectroscope, these images can be seen. The images obtained will be in the shape of parallel lines grouped adjacent to each other, with uniform spacing. When moving from the higher to lower wavelength side, the lines will be further apart on the higher wavelength side and gradually close on the lower wavelength side. The series limit is the shortest wavelength is the fewest separated spectral lines. All the spectral lines observed in the hydrogen spectrum can be classified into different series: Lyman, Balmer, Purchan, Brackett and Font series. C is band spectra. Band spectrum is the name given to groups of lines so closely spaced that each groups appear to be a band. That is, it appear distinct bright bands and produced by an excited source in molecular state. Example: spectra of molecular hydrogen, carbon monoxide, NH3 etc. are of this type. Absorption spectrum. When white light having all the wavelengths of visible region is passed through a medium and the transmitted light is dispersed by a prism, a few dark lines are obtained. These dark lines depend on the nature of absorbing media, and the spectrum is known as absorption spectrum. Like emission spectra, the absorption spectra may also be continuous, line or band spectrum. Absorption spectrum contains less number of type of wavelengths in the emergent light than that in incident light. Difference between emission and absorption spectrum. Emission spectrum, it gives bright lines that is colored on the dark background. Absorption spectrum, it gives dark lines on the bright background. Emission, radiation from emitting source are analyzed by the spectroscope. Absorption, it is observed when the white light is passed through the substance and the transmitted radiations are analyzed by the spectroscope. Emission, it may be continuous if source emits white light and may be discontinuous if the source emits colored light. Absorption, there are always discontinuous.